So, Andrew and Caro, I think you're the only one that's gone for your HPrecalc exam. Good. Remind me real quick how many guys that will be gone tomorrow for WAP? Okay, a few more. Okay. So those of you guys that did not just raise your hands, you get tomorrow to be a work day, study day, ask me questions day. For those of you taking WAP, that's what most of today should be. That's what most of today should be. But if you have extra questions or need to do extra work, that is on you. Remember, we're extending the quiz another day. We should technically have the quiz tomorrow, but we're having the quiz Friday. Oh, test. Sorry, quiz is pre-cal. Lo siento. I said quiz last period. It's stuck in my head. The test is on Friday instead of tomorrow, so that WAP kids don't get a day behind. Okay, let me freeze the screen. You guys keep copying the example. Trying to follow along with the steps that are done. Eileen, we have a makeup homework spiral, so it's excused late back there. They were absent. And then corrections like normal. Yeah, and I think the grades are under my keys. Thanks, kid. Today is Wednesday, but yesterday they had their AP, so we had all the yumminess plus some yesterday instead of today. In case you're wondering where the coffee is. To be honest, there's no way it would have still been around by now. Either way. Lo siento. But next Wednesday, we'll have our final 0 period. On the day of the final, yeah. Which would be 1, 2, 3, Friday morning. Get your own coffee and donut holes. Remember for finals how I spoil you? Time is running a little short. If you want to come back on June 28th. Oh, nope, I will not be in state. Never mind. Ignore that. You can celebrate your own Tau Day. If you guys do decide to celebrate Tau Day, just pop me an email with however you celebrate on June 28th. You can have 2 pies. No. Thanks, David. No, it'd be a normal Tau, but I don't know how you can celebrate Tau Day. Like, what do you have with a Tau? Just have 2 pies. See, it's so much easier. Beach day with a towel? Yeah, I mean, I guess that's one way. T-A-U. 1 Tau is 2 pies. That's what I was saying, just have 2 pies. Okay, we give up. Once you guys finish copying the example, you can grab out your calculator and see if you can figure out where I am right now. I am on number 4, function integrate. How did I get there? This looks kind of like a little hidden menu. Looks kind of like a little hidden menu. Can I get the calculator on top? Alpha, that's a great idea. Look at you, smarty pants. P.S. Happy Wednesday. Can you guys tell that my calculator was updating for 2 hours this morning? Hence why all of pre-cal notes are like all over my boards. Huh? It literally like took it 2 hours and 20 minutes? 2 hours and... It finished right at the end. 2 hours and like 25 minutes to update. I was like, oh my gosh. Well, it was a big update too, but still it was rough.
In the library, you have to come at 7:30 to print off on paper.
It's so true. It takes like 15 minutes to like get.
15 minutes to load in your login, and then 15 minutes to
Believe me, I feel it every day.
It only takes like 2 minutes.
It's like my Google Drive.
Yeah, I know. I feel so cheated right now.
Why?
All of the stuff that we like go to math for is literally all here.
Okay, did you guys figure out how I got to this hidden menu on the calculator? Alpha what? Yeah, you can do alpha y equals and then window, but have you guys checked that you can actually jump straight to alpha window? You can jump to alpha window, you can jump to alpha trace, you can jump to alpha zoom. You can actually jump. You can go to alpha y equals and then go over, or you can just jump to the menus. Anyway, super cool. Oh, I just erased the really cool one that I wanted. Oh, it's right here. Wait, I can do this. Hold on, give me a second. Ooh, life lesson. Can you guys tell what I'm doing right now? Yeah, I'm tracing what I erased. Sometimes in life, when you erase things, they're not really gone. AKA, be careful of whatever you do online. Just because you delete it doesn't necessarily mean it's gone. That has ruined many a life, just a warning. With our day and age. I mean, hopefully you wouldn't be making poor choices anyway, but just because you don't think you posted it publicly doesn't mean that it can't ever get in the public spotlight. So please, please, please. Poor Thomas. Okay, did you guys hit the function integrate? What shows up? An S, kind of. It's actually an integral sign, but it did come from the letter S, summa, summation. It was just basically created as a sign. Yes, it is called an integral sign, but it did technically come from just an elongated S for summation. But anyway, do you guys see what I wrote down there? Why did I put 0 to 1? Did anybody figure that out? Without even knowing what that little S sigma, not sigma, sorry, the integral sign, what it really does. 0 and 1 is A and B. Good. Starting at 0, going to 1. Why did I put an x squared? Because that's the function. And why did I put a dx? It's the notation. So just hang with me there. It's the notation. Some of you might be flashing back to dy dx was a derivative. Differential y over differential x. So maybe that's coming back a little bit. So you can go ahead and plug that in and go, okay, let's start at 0. Let's go to 1 of the function x squared with a d, what variable did I use? X. I could do an a squared dA, I could do a l squared dl, I could do a p squared dp. This d is kind of just identifying what terms I'm working this out in. But what did you guys end up getting? Dun, 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 dun. Dun, dun. Now, here's something even cooler. I want you guys to go to your y equals. I want you to put in x squared. I want you to do zoom standard and then zoom in. Zoom standard and then zoom in. Right around 0, 0. Then I want you to go second trace. I want you to go find the, number 7, the integral of f of x dx. Then I want you to answer the question lower limit with A and upper limit with B, 0 to 1. Dun, 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 dun. Dun, dun. Y equals, I put in my function x squared. I told it, well, after I went to second trace and I went and found the integral, which was number 7. I had to tell it the lower limit, which is 0, and I typed that in. And then the upper limit, and then I hit in, and then it went, there you go. What's wrong? Wait, why comma? Does it put like function integrate parenthesis? Oh. Is there any like integral function? Oh. Lo siento, you can't do it. But you can see it real good and be like, hey, it's right there. I just don't know. I don't know. I don't have any clue what it is. Any questions about how to use the integral-y thing? So, have the first big problem of calculus, the tangent line problem in section 12.3. And what answers that problem? Let's say for this x squared, let's say I wanted the slope of the tangent line, not using all the crazy geometry stuff from the conic section-y chapter, but instead, what is wrong? Hi, what's going on? There we go. Using my calculator, how could I find the slope of the tangent line, say, at -1? Do you remember which guy I used for the slope of the tangent line? Good, dy dx, number 6. And what's the snazzy term for that, dy dx, for the slope of the tangent line? Yeah, say it louder. Differential y over differential x is what the notation is, but it's a derivative. It's a derivative. Yeah, I heard a couple of you say it. So you would hit number 6 and then, oh no, I don't know what's going on. Oh, go to -1. You have to tell it where to go. And -1 would be the slope of the tangent lines. Then you could go ahead and remember, if I have a slope and I have a point, -1, 1, I could go over here and I could say y minus y1. Y minus 1. So I'd add 1 to the other side. Plus m, which is -2, times x minus x1. X minus a -1 will be +1. So I could steal that -2 and do point slope form, and I could go ahead and get my tangent line. Zoop, there it is. Using the derivative feature. And how do I answer the second big problem of calculus? The area problem. With this little guy called, what did I call this elongated S? No, derivative is number 6, answering the tangent line. Integral is number 7, and area. But how do we do it by hand? Well, for us, for right now, we take a limit as n goes to infinity of a Riemann sum of the areas of the rectangles fit in underneath. I should say area of n rectangles fit in underneath. And how do I do a derivative? I do the limit as h approaches 0 of f of x plus h minus f of x all over h, the limit of the difference quotient. The two huge ideas after we learned what limits are from chapter 12. Dun, 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 dun. Okay, so with that, can I give you guys one more example? So I'm not sure that you guys writing down what I did really helped you tons and tons, but maybe it gave you an idea. Let me give you one to try real fast. Hey, actually, people who did homework, did you have any of these in homework? Where you had to go to infinity and beyond? How about this entire section between 37 and 46? What does it say? No. Use the limit process, limit as n goes to infinity, to find the area, the approximate, no, the actual exact area of the region bounded by the graph of the function. And that, wait, isn't that the formula that you just wrote down? Isn't that the limit as n goes to infinity of the Riemann sum from I equals 1? That's how to find the area. Okay, so somebody really cool who started homework. What's one of your homework problems? Oh, I didn't give you any of these?
That's okay, though.
No, you guys are going to do one of these at least. Okay. Hold on, pause. The workspace is a great place. However, if I'm giving you these for homework, I think you might want to hold on to it. So here, ready? Bum-ba-dum-ba-dum. Let's do 33, 39, and 43. Okay. Zoop, zoop. Kiddos, if you wrote down your homework, you better add these in or else you're going to lose some points. 33, 39, and 43. 33, 39, and 43. 33, 39, and 43. Which one do you guys want me to do? 33, which is a parabola, 39, which is a line, or 43, which is a cubic?
Cubic.
All right. Number 43, we're going between, now wait. Can you guys actually maybe plug this into your calculator and know the answer before we even start? Yes. Pause. If I were you, try to use your integral to figure out the answer that we're aiming for before you even start using that cool integral-y thing that we just did. So use your integral, what we just did. Use your integral, alpha window, or you can use the graph and you can do the trace of the function 8 minus x cubed on the interval 1 to 2. And as you guys are doing that, I'm going to go ahead and go back to the zoom. I'm going to your homework page to make sure everything's up to date, especially for Andrew and Carl. All right, you guys got the answer? Don't tell me. Shh. Of the function 8 minus x cubed on the interval 1 to 2, which means a equals 1, b equals 2. Where are you guys finding the integrals? No, using your calculator. Oh, 1 to 2. Oh, I didn't freeze? I am so sorry, guys. I thought I froze the screen. Lo siento. There you go. It's 1 to 2, right? Making sure we're all on the same page. I added 33, 39, and 43. Go team. Zoom. All right, double check the people in your group. Are you guys all getting the same answer? You should. Remember, you have to change your y equals or else you're going to be doing it of the wrong function. Do you guys get 4.25? 4.25, what would that be as a fraction? 4 and a fourth. Wouldn't that be 17 fourths? Okay, so let's come see if we can get 17 fourths. So you guys have the formula in your notes. If you want, you can do this in your workspace, so it will be in your homework spiral for when you do homework. Or you could do it in your notes and just hopefully you use your notes for your homework anyway. What's the formula say? The limit as n goes to infinity of the sum I equals 1 to n of what? What's your formula say? F Good? So who's my, well, I mean, I could start rewriting this, right? Because it's like, okay, I'm taking a limit, got it, and it's going to infinity because I need the rectangles to get infinitesimally thin. F of, who's the F I'm plugging into? Technically, isn't it a G, but can't I think of him as being an F? Is that okay for right now? It's the guy I'm supposed to be plugging into. So it's going to be 8 minus somebody cubed. That's going to be the F of part, which is this whole guy. Then I'm going to have my, well, okay, let's just do the b minus a because it's easy. B minus a, wouldn't that be 2 minus 1 all over n? Oh, hey, okay, that's right, the a's and b's. So a is 1 plus, good, 2 minus 1 all over n, all times, whew, Okay, take a limit. No, we're not ready yet. Can we simplify anything? Good. 2 minus 1 is just 1. What else? 8 minus who cubed? What can we do? 2 minus 1 is just 1 over n, right? So we could do 1 over n times I. Wouldn't that just be I over n? Then I have 1 plus. Okay. Whew, that's a little bit better. Help. We have to use all of our formulas from section 12.5 in order to be able to start simplifying stuff. Any ideas? We could distribute the 1 over n. Do you think we also have to do this cubey thing? Can anybody help me with cubing? Can't we use Pascal's triangle to make things a little easier? What are the coefficients of the row for cubing a binomial? 1, 3, 3, 1, right? Couldn't I maybe make this guy, I don't know if it helps, but make this guy like the x, make this guy like the y, and then, right? So wouldn't it be 1x cubed plus 3x squared y plus 3xy squared plus 1y cubed? You kind of remember binomial theorem? You could FOIL. You could multiply 2, square it, and then multiply another one, polynomial multiplication, totally fine. But Pascal's might be a little easier, which would be 1x cubed plus 3x squared y plus 3xy squared. We're going to use that pattern for simplifying him. Someone said to distribute this guy, right? Okay, so I'm going to have 8 over n. Yay. Plus, minus, because it's a minus, right? Minus 1 over n times. Is that okay? Distributed the 1 over n. Now it's time to use my Pascal's triangle. So I'm going to cube the first guy. So cube 1. Sweet, that's 1. Plus, now I'm going to do 3 times 1 squared. Okay, that's 1. Plus 1y. Okay, that's I over n. Then I'm going to do 3 times just 1 to the 1. Okay, that's easy. Plus I over n squared. Wouldn't that be I squared over n squared? And then we have this last guy cubed, which would be I cubed over n cubed. Whew. Okay. Take the limit. No, 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 no. Remember, we have to get rid of the sum. Oh. Okay, so we're going to have the limit as n goes to infinity. Some of you guys might want to start looking at those highlighted formulas because we're going to need them pretty soon. 8 over n minus, now it's time to bring this guy in, 1 over n. Wait, what's 8 over n minus 1 over n? Oh, okay, let's just do that. So then that gets rid of that guy and then that guy. Then I have minus 3i over n squared minus 3i squared over n cubed. I'm distributing this 1 over n. And then I have minus I cubed over n to the 4th. I can make this the limit as n goes to infinity of sigma of I equals 1 to n of 7 over n. Wait a minute. Aren't we wanting to use those formulas? Okay. Don't those formulas say that we can split this up and take it one term at a time? Okay. So let's do the sigma. Let's pull out the 1 over n, and we have 7 minus. We can pull out the 3 over n squared, sigma, and I'll just leave the bounds for right now to make it easier, of I, minus sigma, oh, let's pull out the 3 over n cubed. This is definitely getting worse as I go. minus, what do I have? 1 over n to the 4th sigma. Okay, let's come up here. Okay, what is my formula for sigma? That's a sigma, just pretend, of a constant. That's a formula, right? C times n. So I'm going to have 1 over n times 7n. Oh, 1 over n times 7n. Isn't that just 7?
Yes.
Okay. And then I'm going to have 3 over n squared times, what's the formula for the sigma of I? No. Isn't it n times n plus 1 all over 2? Okay, good. Minus. Now I need the one for I squared. Hold on. 3 over n cubed times I squared. Isn't that start off the same? Then what? 2n plus 1? All over 6? Take a mental picture. I can't even keep going because I'm running out of room. There we go. Let's get this puppy back where he needs to be. Whew, all right. Minus 1 over n to the 4th. Uh-oh, guys, what's the one for I cubed? I'm going to end with him. N squared parenthesis n plus 1 squared all over 4? Whew! Let's see what we can do. Remember, when you go to infinity, this is section 12.4, to infinity, you always do degree tests, right? Always do degree tests, right? So the limit of a constant. I guess it's tide over tide? I guess it's tide? So that'd just be 7. Okay. I didn't rewrite limit because I'm doing degree tests. Lo siento. So I've done that guy. Now minus. Now it's this guy's turn. What's the degree of the top? 3n squared. So it's squared over 2n squared. Aren't they a tie? N squared over n squared. What's the ratio of the leading coefficients? 3 over 2. Minus. Now it's this guy's turn. N times n times n. That'd be an n cubed. Oh, hey, they're tied again. What's the coefficient on top here going to be for the biggest term, forgetting everybody else? 3 times 2 is 6n cubed over 6n cubed. Isn't that 1?
Yes.
Sweet, last one. N squared and n squared will be n to the 4th, right? That's just times 1. So it's a 1n to the 4th over 4n to the 4th. Once again, degrees are tied. 7 minus 1 is 6 minus, well, I guess we could do it this way. Can we just make everything fourths? I'm trying to get to 17 fourths. So we have 28 fourths minus 6 fourths minus 4 fourths minus 1 fourth. 28 minus 11? Are we thankful for the integral? Yes. Do we know how to do it by hand any other way than the way that you've just seen? No. But what will you learn in calculus second semester? How to do it by hand without any of that. Ooh. But it's impossible for me to show you right now. Ryan.
Distribution of the ends. So
I didn't fully multiply, did I? All I was looking was for the very biggest one. Why was I looking for only the biggest one? That's the only one I need when doing my degree test. So I ignored all the distribution but the very biggest one. So I just looked at the n squared times 3 and I ignored the rest. I was just looking at the n squared times 2n cubed times 3, 6n cubed. I was only looking for the biggest one. I ignored all the rest. I was only looking for the n squared times n squared, n to the 4th times 1, and ignoring all the rest. Now, could you multiply them all out? Yes, but none of the other stuff would matter, the biggest one. John. Yeah. but I might ask for some work shown and tell you to use the limit process for a tangent line or area. But could you double check with your calculator? Kiddos, I'm going to go ahead and while I'm answering final questions, I'm going to pull up. Actually, let me do this. You only had 2 evens? Check your 2 evens if you tried homework last night. They were just filling in formulas and saying area? Huh, go team. And why don't you guys work for the last 7 minutes of class? If you have any questions, let me know. Kevin.
When you're writing a bunch of summations, do you have to write the I equals 1 and all of them?
If you already have the summation at the very beginning being I equals 1 to infinity, and then you're just going ahead and solving, for our purposes in pre-cal, no. Do the quick little sigma like I did. Yeah. Yeah. On homework? Okay. Wait, no, it's 39, right? 33, 39, 43? Okay. Rebecca had questions on 25, 27. I'm going to go peek at those real quick. Let's just do the first one. Sound good? Because those of you that did homework, you're like, ooh, it was hard. And those of you that didn't do homework, you're like, ooh, I want to know how to do it now. So let me steal this. For those of you guys that are checking out the question on number 25, boop, I am grabbing up my calculator because you're definitely going to be using your calculator. I'm going to be putting in the function for number 25, if I can get it circled. The function was negative 1/3 x plus 4. Okay. I am going to use basically the formula that we just talked about, except we're not going to infinity. I'm going to use the formula that we just talked about, except I'm not going to infinity. So I'm going to take off the limit as n goes to infinity. All right, my sigma, I equals 1 to n of f of, where am I going from? A is equal to 0, b is equal to 12. Does that make sense with the beginning and the end? Okay, so I'm going to do a 0 plus b minus a 12 over minus 0 all over n times I times 12 minus 0 over n. So I did everything but the limit. Then I can go ahead and use my f. I'm going to figure out who this guy is to plug in just a second. And I have 12 over n. And then I'm going to say 12 over n, because 0 plus the 0 cancels out. 12 minus 0 is just 12. 12 over n times I. Now what's the cool thing? Can't my calculator do this? So even though we could do it all by hand, this would be an appropriate use of your calculator to say, wait a minute, hold on, I can do sigma. And I can do sigma quite well by just going math summation, which is number 9. Nope, number 0, just kidding. You can even use a little I if you really, really want to. It's just kind of awkward to find him wherever he is. There's a little I somewhere. We can use a big I if you want. I equals 1, 2. Now wait a minute. I'm not going to put n. I'm going to put who n is in my table. What's the very first n that I need? 4. Good. And I'm going to come over here and I'm going to say, okay, so I have negative 1/3 times, if you want to, you can use your little alpha y equals 12 over, now wait a minute, hold on, not n. Who's n again? 4 for this guy, good. Times alpha I, because that's the variable that I'm using, as you can tell right there. Who else do I need? Plus 4. Plus 4 times, now here's a struggle. I just ended my summation, which is not good. I don't want to end my summation, so I need to actually go back to the beginning and say, oh, hold on, I should have put in another extra parenthesis. Come on. There we go. There we go. That way I could go ahead and end this and still have my 12 over n alpha y equals. That's putting in this last part. My n is 4. Now I know this is super tedious. Nope, I don't want it there. But the nice thing is, as soon as you put it in once, oh, what did I do wrong? Too many parentheses. Check, check. Oh, it took away my parenthesis. Becca, the cool thing is once I have it in once, all I have to do is go back and change it all. Oh, it still doesn't like it. It's getting rid of my parenthesis. Oh, that's why. You guys see it? I put one too many. He doesn't belong. Goodness gracious. Change the n to whatever you need it to be, to 8 to 20 to 50. So go up and steal it and copy it. Did it work for you? Mine's being dumb. I think I typed it in the wrong order. Something's funny. But that's what you want to do. Just change it to 8 and then 20 and then 50.
Quick question: do you think I may have accidentally put my wrong email on the AP? You know, like affect, like you know what
Ask Mrs. Pratt.
Okay.
She would know the details.
Okay.
Ultimately, like on your booklet that you have, it should still be able to link to your account on College Board, I think. Double check. I don't know. Sorry, bud.
No,
Is it one that, like, you're worried because Heritage is going to be shut down? Is it like a Heritage
no,
one?
it's not that. It's just like I forgot to put, like, it's my first email. It's austin1@gmail.com. I just forgot the one.
Yeah. Talk to Mrs. Pratt. She might be able to let you change just your information.
Okay.
See what she says.
Okay.
Sorry, bud.